Hello, I will be presenting our work on modeling multimodal social interactions, new challenges and baselines with densely aligned representations. This research was conducted jointly by the University of Illinois Urbana-Champaign and Georgia Tech. First, let's watch a video clip that includes social interactions.
I'm so
We're gonna get you
sorry.
something better than a job.
An education.
Oh,
Get you some knowledge and you'll be fireproof.
oh yeah, that's right, Larry. You're never too old to learn. Just listen to my husband. He hasn't called a man boss in years.
Yeah, I remember why.
The key features of real-world social interactions are that it involves multimodal social cues, including not only verbal cues like utterances, but also nonverbal cues like gestures and gaze. Social interaction also often involves conversations between multiple people, which adds complexity to interpreting interactions. Our research question here is, how can we model the fine-grained dynamics between multiple people by leveraging these multimodal cues, which have not been properly explored in prior works? To address this, we introduce three new social benchmarks: speaking target identification, pronoun coreference resolution, and mention player prediction. Speaking target identification is to identify who a speaker is talking to in a conversation, and pronoun coreference resolution is to determine who a pronoun refers to in a conversation. And mention player prediction is to predict who is mentioned by name in a conversation. All of these tasks are about identifying target reference in multi-party conversations from verbal and nonverbal social cues, which are language and visual cues here. We built these benchmarks based on social deduction game settings that include rich multi-party interactions. The core challenge is that solving these benchmarks requires understanding individual-level, fine-grained verbal and nonverbal interactions, which is difficult for prior works due to the lack of densely aligned multimodal representations. Here, visual information is not densely aligned with the language cues from the conversation. The visual scene is considered as a whole, and it does not correspond to individual utterances in the conversation. This lack of dense alignment makes it challenging to interpret the interaction at the individual level. In the conversation, we have multiple speakers. Without aligning the nonverbal cues with the verbal cues, it is hard to determine who is speaking and to whom they are referring. In the bottom section, we demonstrate our approach of densely aligning individual nonverbal cues with the corresponding verbal cues. Here, each individual in the visual scene is distinctly identified and linked to their specific utterances in the conversation. This dense alignment enables interpretation of verbal and nonverbal cues at the individual level, which helps to understand multi-party interactions between individuals. Here is our proposed baseline model with densely aligned representations for the three social tasks. First, language-visual alignment step synchronizes language and visual cues to identify individuals in both domains via visual tracking. This allows us to visually distinguish a speaker and listeners for a current utterance. Based on the body key points of people, the green part encodes the nonverbal behaviors of a speaker such as gestures and gaze, while the purple part encodes the positions of the other players. As a result, these parts capture the visual interactions between a speaker and listeners. The lower part encodes the utterance language and integrates the surrounding conversation context, including preceding and following utterances. This captures the semantic and contextual nuances of the dialogue. Finally, we fuse aligned language visual features to predict the target referent. The model thus identifies the person based on both verbal and nonverbal cues. We conduct experiments on our three new social tasks with different language models. Our baseline model with densely aligned representations consistently outperforms language-only models and multimodal models without dense alignment, which demonstrates the effectiveness of densely aligned representations in capturing the fine-grained dynamics of multi-party interactions. This slide presents qualitative results on our three social tasks. In each task, the language models alone makes incorrect predictions, while our multimodal baseline model accurately identifies the targets. In summary, we introduce new multimodal social benchmarks that require fine-grained understanding of multi-party dynamics. We propose a novel model that achieves this through densely aligned language-visual representations. Our results demonstrate the importance of dense multimodal alignment for multi-party interaction understanding. Thank you for your attention. You can check out our project page for further information.